Okay, so knowing why the Modbus protocol was created helps in understanding how to use it and what applications to use it and also its limitations. So for quite a while, process plants would be controlled by large microprocessor-based systems called distributed control systems, or DCSs for short. In a typical DCS, there would be one central control system that would control the entire plant. All of the sensors and actuators would then be wired from their point of installation all over the plant, all the way back to the same central control system. This central control system would be housed most often in the control room of the plant. Now, DCS systems are very expensive to purchase and maintain for several reasons, including the expensive cabling and the cost of that expensive cabling. You see, every sensor and actuator had to be run from their point of installation all the way back to the central location. That's a lot of cabling, so it's high maintenance costs. So, attempt to reduce these costs, a company called Modicon invented the first programmable logic controller, or PLC. PLCs were much cheaper but very powerful control systems devices that could be located at different points in the plant. They were cheaper to purchase, install, and operate, and also resulted in a drastic reduction in cabling in the plant, hence cost, because every sensor and actuator only had to be wired back to their local PLC and not back to the control room. Now, the downside of this approach was that the different parts of the plant still needed to know what the other was doing. Hence, there needed to be a way for the various Modicon PLCs to communicate with each other and share their data. All right, and that's what the diagram shows there. 3 PLCs with actuators and sensors connected to it and the need to exchange data. So in 1979, Modicon came up with the Modbus protocol. Modbus stands for Modicon Field Bus, and together they make Modbus. Using the Modbus protocol, you could now interconnect all of the PLCs in the plant with a single communications cable and have them share data. This sharing of data via the Modbus protocol allowed the PLCs to coordinate their activities, resulting in a fully functional and effective plant control system. Really great stuff. So Modicon published the standard as a free open standard. They didn't keep it to themselves. Now, since the protocol was and still is in fact very simple to implement and is also quite flexible, it was quickly adopted by other manufacturers of PLCs. Soon, not only PLCs and microcontrollers supported Modbus, but a host of other intelligent control systems devices from a range of manufacturers. The effects of this rapid adoption has resulted in the Modbus protocol still being the most supported communications protocol in the process control industry. Most devices from manufacturers will support their own proprietary protocol plus Modbus. So in conclusion, the Modbus protocol was born really out of a need to utilize PLCs to run process plants in a more cost-effective manner. Modicon could have not predicted that it would spread into all the areas of the process control scale and automation as it has. Okay.